I don't know if you've wondered how muscles work, but I'm going to be applying that theory about how organic muscle works to a robot in this video and see if I can create an actuator that is inspired by the way our muscles work at the microscopic level. I'll explain to you a little bit about muscles. So this is going to be our muscle at the microscopic level. This little red one is basically going to act like it's rowing or hands grabbing a piece of rope. And this is going to act like our water or like our piece of rope. And this is, in muscle, is our myosin molecules, or proteins. And this is our actin proteins. So it kind of acts like a ratchet. So you have the little latches come in and they pull. And as they go further and further, they pull more and more and create more and more travel for the actin. And this process is what causes our muscles to contract. So our muscles don't expand, they just contract. And that's why we need two sets, one on one side and one on the other, so that as one contracts, the other can let go. And that's how we can move our muscles around. This model is really simplistic, but it kind of sets the idea. And that whole theory is called sliding filament theory. So we're going to apply sliding filament theory to making a robot, or a robotic actuator, a robotic muscle. And we're going to use two components in order to do that. We're going to use some solenoids, which are in this little blue wrap, basically a coil of wire that we charge up, and that pulls this rod into that wire. And that process allows us to get the movement that we're going to be using. And we'll have a little Arduino controller, which will also let us control the whole process so that it can basically pop in and out. It definitely didn't start off with like a simple plan. There were some experiments that I did, and they pretty much failed. Like this was one of them. It's it's kind of a spiral-shaped tree of fairly soft TPU filament, but it in the end was way too rigid because everything was too thick essentially. So I went and I made a thin one where these would be our little rowing oars, and they were more bendy, but that one didn't work out either. And you can see I have it on a motor because I had theories about how the myosin moves inside the actin. So like, let's say this is the actin, this is our water, and this is what would be pulling on things. And the idea was that it would travel inside this, and just because it was in a spiral would kind of pull the actin into it, so that would cause the contraction. But that was really a failed theory ultimately. But I did try a bunch of different actin shapes. So here's a spiral shape on that one, thinking that it would almost act like a screw-in nut, so that the threads of each of them would interact positively. But those failed, and I'm like, okay, I'm gonna try a tighter filament for this or a tighter spiral, I mean, for this to travel inside of. But that didn't do a good job either. And I even went and made a whole like basically Christmas tree of rope attached to 3D printed pieces to try and see if that would help it, like as it moves inside the spiral cage of actin. So this is my myosin doing all the grabbing on, theoretically, and this is the actin, and the part being grabbed onto. So there was nothing special about these. These were just these little like lobe heart-shaped pieces that really were my attempt to mimic some of the actual looks of these proteins. And in the end, none of those worked out. So that's why we switched to the solenoids and a more traditional understanding of sliding filament theory for how muscles actually work. I like showing my failures, and these were just a few of the tests. So with my weird theories out of the way, it was time to get back to the normal way of trying to mimic muscle. I'll briefly show you the solenoid and the circuit that's connected to it. So let's take a look. This is a simple circuit. Okay, so here's the Arduino, and here's a little MOSFET that will do the actual switching of power for our solenoid. So I have a diode here, that flyback diode, that will prevent the current that builds up in the solenoid from being released as a spike once the circuit is off, and then some necessary resistors for everything to work smoothly. So I'm going to turn on the 12-volt power supply. I have the 5-volt power supply going to the Arduino, which is just meant to pulse the MOSFET on and off. So let's see if it works. Yes, this is very satisfying. It has a good amount of force. It does push. In the other direction, its force is not as substantial, but definitely in this direction, which is awesome. So yeah, this is, once I have this set up in a 3D printed sling, it should work. This is the design that I settled on. The idea here is to hold it in a little plastic casing, and then it has these arms, and the arms are what are going to be doing our paddling motion. And so this is basically what embodies our myosin protein, the myosin part of our muscle. All right, we have the solenoid, sorry. We have our solenoid and our two little arms, which are on springs that allow them to move. And we will see if actuating it is going to do anything useful. Oh, and we kind of need to turn on the Arduino for that. There we go. Ooh, it's too cataclysmic for it. All right, I put this little plunger on, and hopefully that will be able to make sure these guys can't jump out of the way in comparison to the last one. Okay. Yep, there we go. That's the motion we want. Yep, and it has a pretty good amount of force. I can correct that later. Yeah, that's exactly what I want to see. If you want to see any behind the scenes process of how I built these things, it's all on the Patreon, and so I'd like to thank all my Patreon followers, and just I couldn't do it without you guys. So thanks for the support, and if you'd like to support me, follow the link in the summary below. All right, we have the little solenoid kickers, swimmers. I'm gonna turn it on, see if we can get it to swim in the, oh, not really. Oh. So what I could do is I could take this off so it would have more time to return. So that could go away. And what would happen in that case is it would push this part, and then as it's coming back up, it doesn't stand a chance of hitting something until it's right there, and potentially hits that, which it might. And And then the next pair of legs will be ready, they'll be offset, and they'll be able to get to these, that, and then do that. But look at how much gain I get. I go to about here instead of the middle when I push. Like, so I think what's going to happen really is that this arc may have to be just a lot longer, and these whole wedges would go away. So those are the two options: get rid of that or get rid of that. And I think it's going to have to be this. We have our taller myosin, and it also has the new track. So here we go. Let's see if it works. Nope, I narrowed it. I didn't narrow it enough. This setup simply didn't have enough material to contact against, and so it really struggled to grab anything. It occasionally grabbed the little edges, but then it would be in this clear space where it just wouldn't grab anything. This Acton is really different in that what I did is I made both a ramp in the horizontal and in the vertical. So the myosin paddlers will have something to grab against to, and they'll also ramp above and over those pads. And it really did start to work. And now we're trying the narrow one. So let's see. This was really it. By narrowing the channel a little bit, I just made sure that the arms were always grabbing something, and that really made it so that we could have a directionality that it was consistent, and or at least consistent on average. And yeah, it would pull the Acton in very effectively every time. And I even switched it up, so I just let the myosin go and see how it travels along the Acton. I'm exceedingly happy with how this sliding filament worked out, this my little myosin actuator, and it's just nice to see it like travel along the Acton as it's supposed to. So hopefully in the future, I think what I'm going to do is I'm going to have multiple actuators and see how they travel, how much stronger they are, and see what I can lift. Maybe we can lift a brick or something ridiculous. But yeah, that's a different type of actuator that I've really never seen before. And hopefully in the future, I'll have some robotics that take advantage of that. Thank you, everybody, and make sure to be easy on yourself. Bye.